It all starts with one small change, a single line of code, a tiny update pushed to the cloud. Everything seems fine. Then, the world grinds to a halt. In July of 2024, that's exactly what happened. A security update from a company called CrowdStrike went wrong. It wasn't a virus. It wasn't a hack. It was a bug in their own software. This tiny error caused a chain reaction. Computers at airlines, banks, and hospitals around the globe started crashing. Flights were grounded. Banking services went offline. It was a digital pandemic, all because one small piece of a very large system failed in an unexpected way. The problem wasn't just the buggy code, it was the failure to see how that one piece was connected to everything else. We see this pattern again and again. We have to do better. So, what is this systems thinking I keep talking about? Let's forget the jargon for a minute. Imagine we're in my workshop. We're not building a website, we're building a Rube Goldberg machine. Picture a ball rolling down a ramp. It hits a series of dominoes. The dominoes trigger a lever. The lever launches a tiny rocket, a wide shot of the whole chain reaction. Each part of that machine might be simple, a ramp, a ball, a domino, but you can't understand the machine by looking at just one piece. The magic is in how they connect. That's systems thinking. In technology, our systems are like that machine, just 1,000 times more complex. Systems thinking is about zooming out. To get good at systems thinking, you need to understand the basic ingredients. I like to think of them as the 5 core building blocks. Once you see them, you'll start seeing them everywhere. Interdependence. This is simple. Everything is connected. In our workshop, the domino won't fall unless the ball hits it. In tech, your login page can't work if the user database is down. A change in one place will have ripple effects somewhere else. The key is to remember that these connections aren't always obvious. A change to a font size on a website could, believe it or not, slow down the entire page. That can make the server work harder. Interdependence is the golden rule. Feedback loops. This is where things get really interesting. A feedback loop is when the output of an action comes back to influence the next action. Think of a thermostat. When the room gets too cold, the thermostat turns the heater on. The heat then raises the room temperature, which is fed back to the thermostat, telling it to turn off. That's a balancing feedback loop. It keeps things stable. But there are also reinforcing loops. Imagine a viral video. The more people who watch it, the more the algorithm shows it to others, which leads to even more views. It snowballs. In tech, a slow website can create a reinforcing loop of failure. Users get frustrated and hit refresh. That puts even more load on the server, making it even slower. Emergent behavior. No single ant is smart, but an ant colony can build complex nests and find food with incredible efficiency. In tech, Twitter, now X, is a perfect example. Its creators designed a simple tool for sending short messages. Users created hashtags, users created @replies, users created social movements. The system itself gave rise to it. Sometimes this is amazing, sometimes it can be dangerous. Every system has a boundary that separates it from the outside world. Systems are not static, they evolve. So we have these building blocks: interdependence, feedback loops, emergence, boundaries, change over time. Why does obsessing over them matter so much when we're just trying to ship a product? Well, because ignoring them is like building a skyscraper on a foundation of sand. It might look great for a while, but it's destined to collapse. The first big reason is predicting problems. When you see the connections, you can spot potential disasters before they happen. You can ask, if we make this database change, which 3 other services rely on it? Have we tested how they will react? This isn't about being a pessimist, it's about being a realist. Another huge reason is reducing technical debt. You take a shortcut to meet a deadline, but each shortcut is like a loose wire left dangling in the machine. Small bits of sloppiness accumulate over time, creating a reinforcing feedback loop of badness. When you're stuck on a problem, it's easy to get tunnel vision, but a systems thinker zooms out and redraws the boundaries. A resilient system isn't one that never fails. A truly resilient system is one that can fail gracefully and recover quickly. They want to ensure that if one part breaks, the rest of the system can adapt without the user even noticing. That is peak systems thinking. It's not just hoping things won't break, it's planning for when they do. It's building a machine that can take a punch. Take software design. A team that doesn't use systems thinking builds in silos, then they try to connect it all at the end. Nothing fits. A team that does use systems thinking starts by mapping the whole system. Now the cloud spreads your system across data centers worldwide. Systems thinkers are paranoid in the best way. What happens if one data center goes offline? How does our data get backed up? Could a failure in one cascade to others? We treat AI like a magic black box. AI is one part of a larger system. People who collect the data, biases hidden in that data, users who interact with the model, and the society it impacts. The robodebt failure happened because the boundary was too tight. They ignored the human system it plugged into. What is the feedback loop for someone wrongly accused? How do we stop a reinforcing loop of injustice? Think about teamwork and organizational change. A company is a system of people. A top-down, we will now all be agile, often fails. Why? Because the system was ignored. A systems thinking leader introduces a small change. They observe the feedback loop, and they adjust. How will this affect design and engineering relationships? What tools are needed? How do we create a reinforcing loop of collaboration? Treat the organization like a garden to be cultivated, not a machine to be commanded. See how this mindset changes everything. If systems thinking is so great, why isn't everyone doing it? Well, because it's hard. Modern tech systems are mind-bogglingly complex. Trying to hold a map of that entire system in your head is nearly impossible. Risks are often hidden. The connections that cause the biggest disasters are rarely the obvious ones. It's the unknown unknowns. A small change over here can be amplified by feedback loops and cause a massive failure over there. Organizations are set up in silos. Each team has its own goals, its own budget, and its own boss. When you say, hey, slow down and think about the whole company, you're often met with resistance. In the world of tech, the mantra is, move fast and break things. We are under constant pressure to deliver. The reward for preventing a disaster 2 years from now is, well, there is no reward. So the system we work in often encourages short-term thinking, the exact opposite of what we need. So how do we fight back against all these challenges? How do we start building systems thinking muscle? You don't need a fancy degree or new job title. Start small, right where you are. The first tool, ask better questions, not just, what does this do? What does this connect to? What depends on this? What happens if this fails? What could this break, even if it works? Be the annoying what-if person. Those questions force you to zoom out. Make the system visible. Grab a whiteboard or a notebook or a digital tool. Start drawing boxes and arrows. Draw your app. Draw the servers it talks to. Draw the users. Draw the support team. Draw the flow of data. Map together. Shared understanding. Hidden connections become visible. So, you do the hard work. You ask the tough questions. You map the system. You learn from your mistakes. What's the payoff? The results are spectacular. Systems that are elegant, resilient, and even beautiful. Think about software behind FedEx or UPS. Physical system. Digital system. Tracking numbers. Databases. Sorting algorithms. Everything is interdependent. A small delay at an airport in Germany creates a feedback loop that affects deliveries in Tennessee. Consider DevOps and site reliability engineering. DevOps brings teams together. Shared responsibility for the entire life cycle. Tools for automation, monitoring, and rapid recovery. They treat the system as code, understand the whole system, find leverage points. A small database improvement speeds up hundreds of features. A better internal tool saves thousands of developer hours, creating a reinforcing loop of productivity and happiness. You stop patching leaks and start re-engineering the plumbing. Move from reactive to proactive, shaping the evolution of your technology. At the end of the day, building technology is one of the most complex things humans do. We are weaving together logic, data, human psychology to create tools that change the world, and because these systems are so complex, failure is not just possible, it's inevitable. We will never be able to predict every single consequence of our actions. There will always be hidden connections, unexpected user behaviors, black swan events. The goal of systems thinking is not to achieve perfection. It's not to build a system that never fails. That's a myth. The real goal is to fail smarter. Build systems that are resilient enough to survive failure. Build teams that are curious enough to learn from failure. Build a culture that is humble enough to accept failure. When a system fails, it's giving you a gift. It shows a flaw in your mental model. A systems thinker doesn't get angry or blame. They get curious. They lean in and say, "That's interesting. I didn't expect that. What can this teach me?" This is the spirit of science and exploration that I love. It's the spirit of Mythbusters. We didn't just build things, we broke them, we blew them up, we pushed them to their limits. And every time something broke, we learned something new. We learned about hidden forces, unexpected feedback loops, surprising interdependencies. We were learning about the system. That's what we need to bring to our work in technology every single day. Be relentless experimenters, constantly testing our assumptions, updating our understanding of the complex machines we are building. Be the systems thinker on your team. Be the one who zooms out. Be the one who draws the map on the whiteboard. Be the one who asks, "What if?" See the connections that others miss. See the feedback loops that drive behavior. See the people and processes as part of the system, not outside of it. By embracing this perspective, you won't just build better technology, you'll build more resilient companies, better teams, a more predictable, reliable, and humane digital world for everyone. And that is a project worth building. Thank you for watching Priority Problem Solvers. If you enjoyed this video, please subscribe and like Priority Problem Solvers content for more insights and solutions.